So at this point in the lecture series, you should understand that there is certainly a balance between mineralization and immobilization. And there's a sort of a tipping point or a fulcrum whereby each one of these relatively equals one another. And so when we look at a list of organic residue or materials as compared to their carbon to nitrogen ratio, we can draw a line on this list as to where that fulcrum or tipping point is located, roughly speaking. So if you look at the carbon to nitrogen ratio in this column on the right, microorganisms have a C/N ratio of about 8 to 1. And organic matter, this is highly degraded organic material, 10 to 1. When you add materials like fresh manure, alfalfa clover mix, and manure with straw, these all have a C/N ratio relatively low. And then you have corn or sorghum stalks and wheat, small grain stalks, sawdust, pine needles, high carbon to nitrogen ratio materials. If I was to ask you what was occurring down here on the bottom part of the graph, you should tell me, Jim, that is immobilization. And if I asked you what's occurring up here in the top portion of this table, you would say, Jim, that's mineralization. And the sweet spot's somewhere in here. So let's talk about that sweet spot in terms of the balance between mineralization and immobilization. So there is a balance. And when we add residues to soil or amendments to soil, oftentimes when we add an amendment or material that has a carbon to nitrogen ratio greater than 30 to 1, immobilization will occur. And when we add an amendment or residue of a carbon to nitrogen ratio less than 20 to 1, mineralization occurs. And somewhere between 20 to 1 and 30 to 1, these two processes balance each other. And that's important to keep in mind. And so if you ever have an amendment tested and you're interested in the carbon to nitrogen ratio, you can ask for a testing lab to analyze for total carbon and total nitrogen, and you simply calculate the ratio yourself or the lab will calculate it for you. So here's a thinking question. What are the practical ramifications for knowing the carbon to nitrogen ratio of any organic material that you're going to add to your soil or to your compost bin, etc.? Well, Jim, if I know the carbon to nitrogen ratio of the material I'm adding to a soil, I know roughly what to expect in terms of either release or tying up of nitrogen in that soil. Now let's think about a compost bin. Let's say you have a big party and you have a lot of paper plates. You want to compost those paper plates. You can add it to your compost bin, and it likely will take a little while for that to break down as compared to, say, I don't know, leaf clippings or something, because the carbon to nitrogen ratio of paper is really, really high. I would imagine it's at least a 1,000, if not greater. So if you had a compost bin full of just paper plates, it's probably just going to sit there and not decompose quickly because there's very little nitrogen present for microorganisms to utilize to build amino acids and proteins. So you would want to mix in something with a low carbon to nitrogen ratio to enhance the degradation of, say, paper plates, for example. So knowing the carbon to nitrogen ratio is important for understanding the relationship between immobilization and nitrification across a wide spectrum of scenarios.